Hello, in this modern OpenGL video, we're going to be covering point lights. We've covered quite a bit of lighting systems. One way is directional lights, which essentially is a light source that points in a certain direction, hence the name directional light, but it does not have an original location. It's infinitely far away. So if I were to have two objects that were exactly the same, rotated exactly the same way, let's say there's no other lighting affecting those objects but this directional light, no matter how far they are away from each other, or away from each other, they will not be affected differently from the directional light source. Whereas a pointer light is a light that has a actual origin and it emits light in every single direction. You can almost think of a point light like our sun or a star in real life. Yes, you could argue the sun does technically emit different amounts of light from different sides, but we could, for argument's sake, say it emits the same intensity, the same type of light from its origin in all directions. And it'd be very common for, let's say, space games, unless it's like some sort of like ridiculously accurate space simulator, for them to have something like a point light as the sun or the star or some sort of object like that. So here's some diagrams of point lights in action. Implementing it is really simple. First of all, just go to your lighting fragment shader, and in here there's a few things we need to modify. The material, that's fine. We want to comment back in this particular line, because we don't need a direction anymore, because it has a position and it just emits light in every direction. Ambience, diffuse, specular, that's all good stuff, but we also need a constant, a linear, and a quadratic float. We'll show you in a moment what we will be using those for. So float, constant, float, linear, float, specular, and yeah, that is all of the lighting struct done. In terms of frag position, normal text recordings, can leave that. We are still getting, or still outputting a color. We've still got these three uniforms. That's not changing at all. In terms of the ambient, we're still doing light.ambient times by a vector 3, which is of texture, and the diffuse and the text recordings. That does not change. If we go to the diffuse section, we're still normalizing our normal. But what we are doing here now is we are getting the difference between the light position and the fragment position. So we'll comment out this line and we'll put this line back in here. So it's light dot position minus fragment position. The difference, max dot normal light direction, all good stuff. We're still keeping that as it is. In terms of the diffuse, we're still using the light dot diffuse times in it by the float diffuse variable that we calculated right here, and still times in it by this vector 3. Okay, let's look at the specular now. So the view direction, that doesn't change. We're still getting the difference between the view position and the fragment position. The reflection direction is still the same. The specular, let's have a quick look at that. So good. And the final vector 3 of specular, I'm just scanning over this and that is all good. But what we need to add now is something called attenuation, and we'll be using this to sort of factor in like distance, lighting, that sort of stuff. So if I go to here, float, actually I'll put a comment in first, attenuation. So you know what, I'm going to Google attenuation so you can see the effect of attenuation. It's essentially like the dropout. I don't want a diagram, I want lighting. But it's essentially the decrease in lighting as you move away from the object. So yeah, here's a pretty good example. Obviously this particular like light source has a lower fall off. So what happens is the further you are away from any sort of light source, the less light you're getting from it. It might honestly seem obvious, but you need to code those sort of things in. It's like, here's another good example. We got 4 different light sources. I'm assuming they're all the same, and this one has more effect on the ground compared to this one because this is further away. So that's what attenuation is, essentially the fall off. So attenuation flows, because at the moment we haven't had attenuation. If the light source was further away but still the same sort of angle, it still affected our object the same. We don't want that. So if you do float distance, so that's very important, this equals the length of, okay, so difference between the light dot position, let me zoom in a bit, minus frag pause, and now we need to do float attenuation equals 1.0 f, dividing it by the light dot constant plus the light dot linear. Let me move over a bit, and this is multiplied by the distance, which on top of that you add the quadratic, and you times that by the have over too many brackets. You add that to double the distance. So you do distance. No, distance squared. Sorry, not double the distance. Distance times by distance, and let me have a quick look at that. My bad. This was meant to be a multiplication. You do add the light quadratic. I think. Shit, what do I just do? Oh, I just moved the page. Change the page. My bad. So that is the distance and the attenuation calculated. If you want more information about how this works, feel free to check out open.gl, learn OpenGL.com, which these tutorials are based upon. They're great resources, great to accompany these videos. So feel free to check them out. Really recommend them. There'll be links in the description. Now we are just going to be adding the attenuation onto the ambient, diffuse, and specular, simply because, factoring it in, simply because all 3 of them will have attenuation factored in, because they need to factor in distance. So we do ambient times equals attenuation. Just multiply this because it's essentially the same. I want you to pause this video, see if you can figure out how to do the diffuse and specular now. I think you figured it out. Diffuse, specular, and we can get rid of the result. No. Yeah, fine. Just making sure it's all good. Prevent errors later on. If we go to the main.cpp, not many changes we need to do in here, in all fairness. The first thing we need to actually uncomment at this, because we're using the lamp again. Before we didn't use it because we just had that sort of directional general light. Now we have a point light and we want our lamp as well. So if I scroll down, what else do I need to change? Here we go. The light vertex array object, because we're using the lamp shader now. Need to whack this back in. And now the question is, what else do we require? We also need an emission map. So we're going to put emission map, and this can just be emission map. Okay, I think load in the actual textures and specular map, that is all fine. I think the only changes we need to do now are actually within our while loop. So we zoom into this lighting shader. We need to get this line back in because we have a position now. We can comment out the direction because again it emits lighting every direction. It's not in one particular direction. The view position location does not change. We can comment at this, bring this bad boy back in. That looks all good. And now let's check these bad boys. So we're using light.ambient, .diffuse, .specular. They're all good, but we also need to do the constant, the linear, and the quadratic, which are float values. So if we just duplicate this 3 times, modify this to say light.constant, constantine, constant linear. Let me zoom in a bit more. And this needs to say dot quadratic. Okay, so for these, because it's not a vector, we only need one value. For the constant, it's going to have 1.0. I recommend, what's this moaning about? I know what. Let me put the values in and then I'll fix it. 0.09f. I recommend change the values, see how they affect the particular lighting. This needs to be 0.03. It doesn't have to be these are the values I'm using. Like I said, experiment. And the reason it's moaning is because it should be a 1, should be a 1. Because it's not a vector anymore. And we're still setting the material shininess. Still getting the view matrix. That's all good. We scroll down. We're still binding our textures. Need to uncomment this out. So it's going to uncomment this one out as well. And yeah, we also need to delete the vertex array for the light vertex array object. So I think we should be ready to run now. So I'm just building this, make sure it succeeds. Okay, we should run. It should run our application now. Okay, we've got our light. Okay, so in our shader, in the fragment shader, in line 20, duplicate fill name specular. Oh, why did I put specular? It's meant to be quadratic. I'm actually just going to rerun this, see what problems this resolves. That literally resolved every single problem. It's crazy, that is. So we got our original light source, and as you can see, what we've got is, see if you can, the objects that are further away are obviously darker, as they should be. But what we'll do is go to main.cpp and we'll actually move our light. So every frame will slightly move our light. As you can see, attenuation is factored in. See, as you can see, this object is getting slightly brighter now, and you'll actually start seeing this particular object getting brighter, as you can see. So, yeah, honestly, that is it for point lights. But what I'm going to do is comment this back in, and I'll recommend changing the position. So, light position, I want to move it in. I'm going to do -2. This should move it in, and as you can see, the light is being emitted in every single direction, but because it's nearest to these two objects, these are the brightest compared to this one, and then obviously compared to these. So that is it for point lights. If you have any questions whatsoever, feel free to post them on our education platform, sonarlearning.co.uk. There will be a link in the description, plus there'll be a link in the description to the point light images that I showed you off Google. There'll be links in the description to the source code, which I think I may have already, I don't know if I didn't mention that, but either way, there'll be links in the description for the source code. And as usual, thank you for watching, and I hope you have a great day.